morning. My name is M. NARASIMHARAO, lecturer in physics. Today I am explaining minimum length of the mirror required to see the full image of a wall which is present behind the observer. Observer is present exactly at the middle of the room. Now, A, B, D, C, it is the closed room. CD represents the wall. To the opposite wall, I have fixed one plane mirror. MN represents the plane mirror which is fixed to the opposite wall. Which this plane mirror MN is fixed to the wall AB. EG represents the observer. This observer is present exactly at the midpoint of the room, middle of the room. Now, dB distance I am taking as today. This is the total length of the room. Exactly at the middle, a person is standing, observer is standing. E represents the eye of the observer, G represents the feet of the observer. This person is present exactly at the middle of the room. This total distance is 2D. This person is present exactly at the middle. This distance is D. This distance is D. Now, when I am standing in front of the mirror, I am the object. My image is formed behind the mirror. Now, CD is the object now. We want to see the full image of the wall CD in this mirror which is fixed to the opposite wall AB. Now please listen. CD is the object. Its image is formed behind the mirror. C dash D dash is the image of this wall. Now please listen here. MN is the length of the mirror. MN is the plane mirror. Now we want to see the full image of this wall CD. With a light ray which is coming from the top of the wall that is incident on the plane mirror at the point M. When the light ray is incident on the plane mirror, immediately reflection of light taking place. Thus reflected light ray entered into the eye of the observer. Observer is present exactly at the middle of the room. Now, he wants to see the full image of the wall CD which is present behind the observer. Another light ray which is coming from the bottom of the wall incident on the plane mirror at the point N. When the light ray is incident on the plane mirror at the point N, immediately reflection of light taking place. Thus reflected light ray entered into the eye of the observer. From the top surface of the wall, CD represents the wall. From the top surface of the wall, a light ray is coming. That light ray is incident on the plane mirror at the point M. Immediately reflection of light taking place. Reflected light ray entered into the eye. Another light ray which is coming from the bottom of the wall incident on the plane mirror, immediately reflection of light taking place. That reflected light rays entered into the eye. This person EF is the observer. This observer is observing the top surface of the wall and the bottom surface of the wall. The CD is the object to this mirror. Its image is formed at C dash and D dash. We know very well, in the case of a plane mirror, object distance is equal to image distance. Now CD is the object, this is the MN is the plane mirror. The distance between the object and this plane mirror we are calling as the object distance. This object distance I am taking as 2D. dB is equal to 2D. dB is equal to 2D, nothing but the object distance. Nothing but the object distance. Now the C dash D dash is the image of this wall. Now this is the image. The distance between the image and this mirror, plane mirror, we are calling as image distance. Image distance also 2D. In the case of plane mirror, object distance is equal to image distance. BD dash is equal to BD dash is equal to 2D, nothing but the image distance. Nothing but the image distance. Now please listen here. This person is standing exactly in the middle of the room. Its meaning is this distance is equal to this distance. DG distance is equal to GB distance. DG distance is equal to GB distance, that is equal to D. That is equal to D. Now please listen. This now at the MN represents the plane mirror. At the point M, which is the top surface of the plane mirror, at the topmost point of the plane mirror which is present on the reflecting surface, at the point M I am drawing one normal to this plane mirror. This is the normal. Now this is the incident light ray. Now this incident light ray is making an angle with the normal. This angle we are calling as the angle of incidence. Angle of incidence is represented by I1. You know very well. This is the reflected light ray from the plane mirror. This reflected light ray is making an angle with the normal. This angle we are calling as angle of reflection. You know very well, from the laws of reflection, angle of incidence is equal to angle of reflection. These two angles are equal. If the angle of incidence is 30 degree, angle of reflection also 30 degree. If the angle of incidence is 40 degree, angle of reflection also 40 degree. Angle of incidence is equal to angle of reflection. Angle of incidence and angle of reflection both are equal. These two angles are equal. This angle is I1 means this angle also I1. Both the angles are equal. Angle of incidence is equal to angle of reflection. Angle of incidence I1. Angle of incidence I1. Angle of reflection also I1. Similarly, here also, this is the light ray which is coming from the bottom surface of the wall, which is incident on the plane mirror at the point here, bottommost point on the plane mirror, which is present on the smooth surface or reflecting surface. Immediately reflection takes place. This is the incident light ray, it is the reflected light ray. This incident light ray is making some angle with this normal. This angle we are calling as angle of incidence. It is the reflected light ray. This angle we are calling as angle of reflection. Angle of incidence and angle of reflection both are equal. These two angles are also equal. Now please listen here. Please remember one point. This person is present exactly at the middle of this room. This distance is equal to this distance. Keep it in mind. E represents eye of the person. G is the observer standing in the middle of the room. This distance is D. This distance is D. This distance is D. This distance is D. Now this distance also D. This distance, Ln distance is equal to D. I am writing Km distance is equal to D. Ln distance also D. Ln distance also D. EKM is a right angled triangle. F MC is a right angle triangle. Both are the right angle triangle. Both are similar. The reason is this angle and this angle equal. Here the angle 90 degrees. Here the angle 90 degrees. This angle equal. This angle 90, this angle 90. These two angles are also equal. Now EKM is the right angle triangle. FMC is the right angle triangle. Both are the right angle triangle. Both are similar triangles. Both are similar triangles means. Now please listen. This distance you take it as A. EK distance you take it as A. EL distance you take it as B. Now please listen here. In the similar triangles, what are the similar triangles? The triangle E, K, M, comma, triangle F, M, C are similar triangles. Similar triangles. In the case of similar triangles, ratio of the bases is equal to ratio of the heights. Here, in this triangle, base is EK divided by. In this triangle, base is FC. Base is FC. That is equal to. In this triangle, height is Km. Height is Km by. In this triangle, height is FM. Height is FM. Now, here please listen. This CF distance I am taking it as Y1. Now HD distance I am taking as Y2. Now please listen. EK distance I am taking as small a. EK distance small a by. FC distance is Y1. That is equals to Km distance. Km distance is nothing but a small d. Km distance is nothing but a small d. This one. Km distance is equal to GB distance. Km distance is equal to GB distance, nothing but small d. Km means GB, nothing but small d by FM, nothing but dB. FM distance means dB, nothing but 2d. Now please listen here. DD gets cancelled. Y1 into 1, Y1. 2 into A, 2A. Now please listen here. Now here ELN is a right angle triangle. HND is a right angle triangle. Triangle ELN, triangle HND are similar. ELN and triangle HND both are right angle triangle, both are similar triangle. In the case of similar triangles, ratio of the bases is equal to ratio of the height. In this small triangle ELN, base is nothing but the EL means B. EL by. In the big triangle HND, in this big triangle, base is HD. That is equal to height. In this smaller triangle, height is ln. Height is ln by. In the bigger triangle, height is hn. In this triangle, height is hn. Now please listen. EL distance I am taking as a small b. EL distance means small b by HD distance. HD distance I am taking as y2. That is equal to ln. Ln distance. Ln distance nothing but small d. Ln is equal to GB. Ln distance means GB distance nothing but small d. Ln means small d. Hn distance. Hn distance means dB distance. dB distance means 2d. D gets cancelled. Y2 into 1 Y2. Y2 into 1 Y2. 2 into B 2B. This is Y2 is equal to 2B. Now please listen. This distance is A. This distance is B. This is A. It is B. This is nothing but the A plus B, nothing but the length of the mirror. This distance A, this distance B. This total distance is A plus B. This total distance A plus B is equal to Mn, nothing but the length of the mirror. A plus B is nothing but the length of the mirror. Now, please listen. This is A. Now this KE distance A. Now this distance also A. Now this distance EL distance B. This distance also B. Now please listen. Height of the wall CD. Height of the wall CD is equal to Y1 plus small a plus small b plus Y2. Now please listen. CD is equal to Y1. Y1 means 2A. Y1 means 2A. A plus B. Y2 means 2B. CD is equals to 2A plus A, 3A plus B plus 2B, 3B. CD is equal to 3 common. A plus B. CD represents the height of the wall. Height of the wall is equal to 3 into A plus B. A plus B is nothing but the Mn. A plus B means Mn, nothing but length of the mirror. A plus B. 3 I am writing 3. A plus B. A plus B means length of the mirror. Length of the mirror. Now, 3 comes to denominator. Height of the wall divided by 3. 3 comes to denominator. That is nothing but the length of the mirror. Length of the mirror required is equal to 1/3 of the height of the wall that we require. Now, if you extend this reflected light ray, it will meet at C dash. If you extend this light ray, it will meet at D dash. We are thinking the light rays are coming from C dash and D dash. Final image is a virtual image. It is formed behind the mirror. Erect image. Erected image. We can see the image, but we cannot cut on the screen. Now, length of the mirror is equal to 1/3 of the height of the wall. Thank you.